How to add lighting and emission to your own Unity2D project. First, you're going to need the 2D universal render pipeline set up in your project. Luckily, Unity has a 2D template with the URP already built in. Once you have a scene built, any sprite you want to be affected by the lighting needs to use a lit material versus an unlit material. You can pick and choose. For example, my player is affected by the scene's lighting, but I chose to keep the sword slash effect unlit so you can always see it. The lit sprite material can be found if you click the little eye icon and then type lit in the search bar. Next, we're going to add a global light so the sprites will actually stay lit. Messing with the intensity, we can see which sprites are lit right now, since this is the only other light in the scene. I'm going to set the global light to around 0.85 so that everything can be seen by default, but also so that other lights can still light up the scene later on. Now, a 2D light can be added to any object in order to spill the light onto the surrounding environment, but we still need to add emissive textures to make it look like there is an actual light source. To achieve this, sprites use what are called secondary textures. An emissive secondary texture is just a one-to-one copy of the original full color texture, but with all the emissive pixels in white and everything else black. To add the secondary texture, click the drop-down, click Secondary Textures, and add a new one. It has to be labeled _emission for this to work. Once you drag the emissive texture over, you can see they line up perfectly by clicking on and off of it. Next is the most complicated part, creating the shader graph and material. Right-click and go to Create, then Shader Graph, then URP, then choose either the lit or unlit sprite shader graph depending on whether you want your sprite to be affected by outside light sources. Open the shader graph, and on the left we're first going to create two texture 2Ds, one called _main text and the other _emission. Again, the naming is important for this to work properly. We're also going to need a color node with the mode set to HDR. To begin setting up the graph, create a sample texture 2D and attach the main text node to the texture. Underneath this, you're going to want to do the same thing for the emission node. Using the R node of the emission sample texture, create a multiply node. The sample texture should automatically be hooked up to A, and we're going to want to hook up our color node to B. Next, we want to create a new add node to combine the RGBA output from the main text node with the multiply node. The output of this can be attached to the base color of the default fragment node that came with the graph when it was created. Lastly, we just need to make sure the alpha of our main text node is hooked up to the alpha of the fragment node as well, and the graph should be done. Right-click the shader graph you created and create a new material. Doing this will create a new material based off of the graph, and you'll be able to see 3 different settings over in the inspector. From here, we can drag and drop our main texture, the emission map that correlates to that texture, and add the material to the sprite renderer we want to apply the emission to, which in this example is my tile sprite. The last step is to add a post-processing volume to the scene. Make sure the mode is set to global and create a new profile with post-processing and bloom turned on. The most important settings tend to be threshold, intensity, and scattering, but I encourage you to mess around with the settings to create the feel that works best for you. If nothing's happening yet, you're just going to have to jump back over to the material you created and adjust the color and intensity. This material also works with multiple textures as long as the secondary emission texture is applied, as you can see with my tile map. Despite only dragging in one of the tiles to the texture sections, the emission maps of all the tiles seem to use the material, which is really convenient. Now, if you want to take things another step further, you can add a Shadowcaster 2D to your sprites so they'll interact with the light sources more realistically. I manually outlined the top half of my player sprite to cast shadows, and I'm a big fan of the effect it creates. I hope you all enjoyed and found this longer video useful, and happy game making, because that's